Welcome back to the Scotti-BYTE channel, and this is Scott. So today I want to talk about a cheap, well, let's say inexpensive self-hosting server alternative. Subscribers to the channel often want to run a Raspberry Pi for self-hosted applications. If you watch my tutorials, you'll see that I recommend both LXD and Docker containers to host your applications. A Pi 4 8GB model has 4 cores and an ARM processor that runs at 1.5 gigahertz, and right now, well, post-COVID, they're about $175 US, and that's if you can even find one, and they're not really expandable. So there are better alternatives that do offer some expandability. The Minisforum UM350 16GB small form factor PC has 4 cores and 8 threads and an AMD Ryzen 5 3550H, which is one of the Ryzen mobile processors that runs at 2.1 gigahertz per core, and then it has a turbo mode that can run up to 3.7 gigahertz per core. And it has a 256 gigabyte NVMe drive, and that unit sells for $325 US. So what are the specs for the UM350? The Minisforum 350 was released in January of 2022, so it's a fairly new device. It has an AMD Ryzen 5 3550H with 4 cores and 8 threads, 2 megabytes of level 2 cache, and 4 megabytes of level 3 cache. Memory is the mobile variety of the DDR4, and it comes with 2 sticks of 8 gigabyte, and it has only 2 memory slots. So these 2 SODIMMs can be upgraded to 64 gigabytes with 2 32 gigabyte sticks. And then it has an M.2 2280 form factor, 256 gigabyte NVMe drive, and it's a nice fast drive. And then it also, in its lid, has an optional 2.5 inch SATA SSD slot that connects to the motherboard. And then for overall peripherals, it has a 2.5 gigabit Ethernet interface that, of course, can run down at 1 gigabit. But if you have a 2.5 gigabit switch, then it can take advantage of that. It has a 1 USB 3.1 Gen 1 2 amp yellow USB port. So if you see a yellow USB port, it means that when the device is powered down, it still operates as a charging port. And then just to remind you, a USB 3.1 is a 5 gigabit port. And then it has one other blue and 2 other blue, a total of 3 USB 3.1 Gen 2 ports on the system. And the USB 3.1 Gen 2 ports are 10 gigabit. And then also on the front, it has a USB-C, which is a USB 3.1 Gen 2 10 gigabit connector. It also has a clear CMOS where you can poke a paperclip in it to clear the CMOS. That'll become important later when I mention something else. And it has one HDMI port, 1 display port, and then 1 audio jack, and a 19 volt power input that comes from a small power brick that is shipped with the device. It also has a wireless interface, which is an M.2 2230 form factor. It is a Wi-Fi 5, 2.4 and 5 gigahertz, so it's no Wi-Fi 6 or anything, and it has Bluetooth on board. But if we're going to use this as a server, we probably don't care about the wireless. We mostly care about the wired port. And then it has an onboard Radeon Vega 8 graphics, which supports its HDMI connection, the DisplayPort connection, and you can also do video over USB-C, all at 4K 60 Hz. But as you'll find out, I really don't care about the video connectivity because I plan to turn it off because I want to use all the horsepower for this server for self-hosting. So can this be a self-hosted entry-level server? And I believe the answer to that is yes. So my recommendations are buy this with 16 gigabytes of memory and with the included 256 gigabyte NVMe drive, and it will be $325 US. Most places you'll find it will advertise it at $385, but it will have a $60 instant off coupon for the device. So consider upgrading this on down the road to 32 gigabytes or 64 gigabytes because self-hosting really enjoys having a lot more memory. And that's where the shortcomings of the Raspberry Pi come, because having only 8 gigabytes of memory that's not expandable makes it less of a good option for the self-hosted operations. And then on down the road, you could also look at a larger NVMe drive. And in fact, when I bought my unit, I had a 512 gigabyte NVMe drive, which I swapped for the internal 256 gigabyte NVMe drive, which, by the way, comes self-installed with Windows 10 Home. But since I think Windows 10 is mainly a virus, I set it aside in a safe place and did not connect it to my network. So, we're going to install Ubuntu 22.04 server. And Ubuntu server has LXD pre-installed. I found that kind of interesting, but the server variety of Ubuntu 22.04, which of course does not have the GUI, has LXD already pre-installed, and it's very simple to configure it. And then my suggestion is to configure the internal Ethernet adapter, which is ENP3S0, with a bridge configuration, and that's one of the things that we're going to do in the demo, which is really a review of things I've done on the channel previously. And then we're going to add LXD profiles for bridging and Mac VLAN for your main LAN and any VLANs you have, as we have discussed in the past on the channel. So let's go see how to set this system up as a small form factor self-hosting server. So here's the Minis Forum UM350 installed in my data center rack, which I just set it on a shelf there alongside of my Chamberlain garage door bridge and my Philips Hue hub. And you can see that it's a really small device. Here it is from the top of the unit, and you can see also from the front. So on the front here, we have the yellow USB 3.1 Gen 1 port. Next to it, we have a blue USB 3.1 Gen 2 port. All the way to the left, we have a USB-C port. We have a headphone jack. We have the power button. And then there is the CMOS reset that can be reset with the paperclip there. As we turn the unit around towards the back, you can see that there are two more USB 3.2 Gen 2 ports, an HDMI port, a DisplayPort port, the 2.5 gigabit LAN connector, and the 19 volt input for the power brick, which is included with the device. If we look at the top of the unit and we turn it around towards the front, you can depress the springs with your fingers and you can open the top, which is a toolless entry to the case. And then on the left-hand side there, we can see the NVMe, and then we can see the 2 sticks of memory, which right now delivered are 2 sticks of 8 gigabytes, giving me 16 gigabytes of memory in the unit. And here is the top of the case, and you can see that there is an adapter to connect a 2.5-inch SATA SSD for additional storage, and this is the NVMe drive, which is a 256 gig drive that came with the unit, although in my case I had a 512 gigabyte drive that I replaced it with. This 256 gigabyte drive is delivered with Windows 10 pre-installed, and here we are with the Minis form back installed in the rack, and the power light is on and the unit is booted. To install our Ubuntu 22.04 server on this device, we need to grab a thumb drive. In this particular case, I have a crazy large one that happens to be 64 gigabytes, and you probably only need one that's maybe 4 or perhaps 8 gigabytes. In any event, when we go into the startup disk creator in Ubuntu, you select Other, and hopefully you have downloaded a version of the Ubuntu server. In my case, I picked Ubuntu 22.04 server, and it's over on my disk here where I have a list of distros. So Ubuntu 22.04 live server is the one I want to choose, and you can download that from the Ubuntu site. So now that I have the 22.04 live server highlighted and I have the memory stick highlighted, I can click on Make Startup Disk, and it warns me that it's going to delete everything on the Patriot memory USB stick, which is fine, and I click on Yes. It asks for my password. Once I enter my sudo password, it begins writing the disk image onto the USB stick, and once that's completed, then we have installation media for the server version. And you have an option to test your disk here, and I can do that. If I click on Test Disk, it's going to open a virtual instance, and you can see here that it was going to be able to launch this in QEMU, and there it goes. So if I was doing an actual installation with this disk, I would plug it into the Minis Forum UM350 to one of the USB ports, and then at that point in time, I would go ahead and boot up the device, and if it didn't find the boot disk immediately, what I would tell it to go do is I would go ahead and power it up again and hit F11, and at that point it should find it. So here you can see it's actually running the startup. We're running it in a QEMU virtual window because that's part of what we do with the test of the disk, but you would actually be installing it in the Minis forum. When it comes up, it'll ask you questions as though you're installing a Linux desktop, except the interface will all be through a terminal because the terminal is all, there's no GUI in the server operating system. So once you do that, you should have an installation. When you install Ubuntu Server, you're given the option to install it with SSH server, and I did so. So here I can SSH over to VMS Mist, which is the new host name that I have selected. You can see here that I'm running Ubuntu 22.04, and it's Ubuntu 22.04 server, and it has an address on the network. If you install NetTools, as we've covered many times before, and you do an ifconfig, you'll notice on your system, not on my system, that your ENP3S0 device is the thing that is getting an Ethernet address. However, on my system, that's not true. The address is being received by the device called bridge 0. So you have to create a bridge device in order to be able to use this for LXD hosting. And the way that we do that is if you do an ls, after you install server, you're probably going to see a file called 00-installer-config-wifi.yaml, and that's for the wireless device, and we're not interested in that one. But the 00-installer-config.yaml is the one for the wired interface, and that's the one that we're interested in. So I went ahead and copied that file over to .save just so I could have a copy of it, and then I can go in and do a nano, or really a sudo nano, but since I'm already signed in as root here, I am doing a nano of installer 00-installer-config.yaml. And here's the YAML file that we used to build our bridge. We've covered this on the channel before, but basically we specify our physical device ENP3S0. Down here under, we call our bridge, I'm calling my bridge bridge 0. And then I'm saying my interfaces are going to be the one and only interface, ENP3S0. Down here, I'm setting a static address, which is on my main LAN of 172.16.1.50 with a subnet mask of 16, which is correct for my network. You might have something more like 192.168.1. some address with a subnet mask of 24. And then we have a routes via command, and in Ubuntu 22.04, this via directive should point to the address of your gateway, which would be the address of your router on the network. And then I've specified the name servers as being the two name servers for Cloudflare, 1.1.1.1 and 1.0.0.1. Once you've done this, in order to make your configuration take effect, you're going to do a sudo netplan apply, and that's going to go ahead and set it up. But since I've already done that on my system, I won't need to do that. But let's do another if config. And you can see here that I have a bridge 0 device, which is getting my Ethernet address. And I have many other devices. I have a bridge 0.30, a bridge 0.80, which indicates VLAN 30 and VLAN 80. And then I have ENP3S0, which is not getting an address. And then I have the standard bridge for LXD, which is LXD BR0. And then I have a couple of virtual Ethernet devices here. Now that I have a bridge device on my small form factor PC, the next step is going to be to create some LXD profiles, which I've already created here. And if you do a LXC profile list, you can see that I have 4 that I've added to the normal default profile. One of them is a bridge profile, and if I do a LXC profile edit bridge profile, this is a profile that I have created for my devices or my containers that I want to see bridged to the main network. And I talk about bridging in several other videos on the channel, but this says the internal device ETH0 inside the container, which is called ETH0, is a bridged connector, and it uses the parent bridge, bridge 0, and that's basically all there is to it. So anything that's created with this particular profile will be on the main network. Now I also have a profile I call untagged, and this also creates a main or an address on the main network, but this one's different because it uses MAC VLAN. And I do have some videos where I talk about the difference between bridging and MAC VLAN. Basically, bridging is a way to connect two networks together, whereas MAC VLAN is a way to produce a projected address onto another network, which is normally a VLAN. So in this particular case, again, we have device ETH0. We call it ETH0, but the NIC type as opposed to bridge is MAC VLAN, and the parent is still bridge 0, and that's really all there is to that. And then appropriately, I have one for my IoT VLAN, which happens to be VLAN 80, and if you have any VLANs, you can set these up as well for your VLANs. But VLAN 30 looks just like the one we looked at just now. The difference is, instead of not having an entry for VLAN at the bottom, I have an entry for VLAN 30. So when I create a container using these particular profiles, and I've created 4, which coincidentally, if I do a lexi list, you can see that I have a container called bridged, which uses the bridge profile, and it got an address on my main LAN of 172.16.1.89, and I have another container called untagged, which also used the untagged VLAN, and that created a 172.16.1.241 address, which is also on the main LAN. And then I created a container called VLAN 30, which has an address of 192.168.30.184, which is an address on the IoT VLAN. And finally, I created one called VLAN 80, which has an address of 192.168.80.213, and that address is an address on my Cloud DMZ VLAN. Creating these containers is very easy. We've covered that before on the channel. And as an example, to create the VLAN 30 container, I simply did alexi launch ubuntu :20.04 VLAN 30, because that was the name I wanted to call my container, -- profile VLAN 30. And I didn't provide any additional switches, but this is the simplest example of creating a container. If you want to know the in-depth information on creating and managing LXD containers, watch some of the other videos on my channel, and we go into that detail. In order to monitor our system from the command line, I install the BTOP program, and when you bring it up, you can see that it lists all 8 threads of the Ryzen 5 3550H processor over here on this side, and then over here it lists a total of 15.5 gigabytes of memory out of my 16 gigs of memory. And if you installed this straight away and looked at it, you'd probably see 13.5 gigabytes of memory, and be aware that this processor has integrated graphics and that uses shared memory for the graphics integrated with the machine. I went into the BIOS and turned that graphics off and got 2 gigs of memory back, since this is a server and I don't plan to connect a monitor to it. If I ever wanted to re-enable the monitor, that's when the CMOS paperclip on the front of the device comes in handy, and you can reset the machine. So here you can see that I've used 2.23 gigs of memory, which is 14% of the available memory, and there's 13.3 gigs available. So keep in mind, that's the host operating system running Ubuntu 22.04 plus 4 Ubuntu LXD containers running Ubuntu 20.04, so 5 operating system instances are running in a mere 2.23 gigs of memory right now. Now, of course, I don't have any applications installed in these LXD containers, but this is pretty interesting. And then my hard drive, as I said early on, I happen to have a 512 gigabyte NVMe drive, which I swapped for the delivered 256 gigabyte NVMe drive, and I've only used 7% of that drive so far, with LXD installed and initialized, and along with 4 containers being built. So really, it's very miserly with disk space as well as memory. If you're a regular on my channel, you note that I really do like LXDware LXD Dashboard, and here's my LXDware LXD Dashboard, and I have VMS Fog and VMS Cloud, which I frequently talk about on the channel, two of my systems, as well as my desktop system. All three of those are running LXD, and now so is VMS Mist, which is that 172.16.1.50, which is the Minisforum UM350 server. So now you can see at the top level of LXD dashboard, it says that with four LXD containers running, that the host memory is 16.99% utilized, and there are currently 4 containers running. You can see here that LXD and QEMU are fully configured, and we can look at all 4 of the containers, and we can see their IPv4 as well as their IPv6 addresses. So I talk about LXDware, LXD dashboard, and I have another video devoted to exactly how to configure it. So in summary, we saw that the Minisforum UM350 is a low-cost, small form factor PC that can be configured as a rather capable small server. We saw how efficient that Ubuntu 2204 server, along with LXD, can really be. And the 4 cores and 8 threads of the mobile Ryzen 5 3550H provide much more compute power than does a Raspberry Pi 4. The Minisforum UM350 is expandable and offers a nice complement of integrated peripheral options. This Minisforum UM350 is very efficient and draws only about 25 to 30 watts of power. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell.